Thanks. Hello, hello. Hi, my name is Mike Samuel. I'm from Google security team, and I'm going to be talking about Caja today. They have a couple notes that they want me to announce first. Please don't forget to provide us with feedback by filling out the short surveys. And no, that is the wrong set of surveys. That's about lunch. But all right. If you have questions, just walk up to the mics. And Caja is a project that's trying to design a fundamentally secure foundation for web apps that runs in existing browsers and allows people to use the tools that they're familiar with. So if you're familiar with JavaScript and CSS and HTML, it should not be new to you. And I'll be talking, Caja means box in Spanish, and a box is a unit of isolation. I'll be talking a little bit about how to draw boxes and come up with a security model and why the existing browser security model, the same origin model, doesn't work very well for mashups. And I'll talk a little bit about the underlying theory that we're working on. Object capabilities is a theory around how to reason about security in a certain environment. And I should also mention a couple existing tools which are doing similar but different things. AdSafe is Douglas Crockford's JavaScript verifier. So you give it JavaScript and it looks at it and proves to itself that if it can prove to itself that it's not doing anything untoward, then it'll say, yes, this is safe. This JavaScript can be inserted in a containing page, and the containing page can be sure it's not going to do anything unsafe. FBJS is Facebook's JavaScript rewriter. So it takes JavaScript and it converts it to JavaScript with added runtime checks. And Jacaranda is a class-based language similar to JavaScript. It's not prototypical, so porting existing code to Jacaranda is probably going to be some work. And I think Caja is distinct from these in that it works on an entire web application. So it's not just taking JavaScript, it's also taking in the CSS and the HTML as well. And it is a goal of Caja to provide an easy migration for existing code bases to Caja. And I talked about boxes a little bit. I'd like to talk a little bit about the history of interactive documents. And so there have been a lot of attempts to take documents and kind of add interaction to them so that the user can interact. The first really widely used one was Microsoft Office. And Joel Spolsky came up with Visual Basic for apps, which allowed you to embed scripts in an Excel document or in a Word document. And that meant that now an Excel document could reach out into the file system and pull in some information, collate it, graph it, and you could build an entire application in Excel. But it could also do an awful lot of other things. So it could delete files on your system. It could do just about anything that the current user could do. So that worked very well as long as you trusted the person you got the file from. And if they got that file from someone, you transitively trusted who they got that from. And that worked within the bounds of a small company. So if you trust all of your office mates and you're just trading files on floppy disks, you can trade back with them. And since you trust them a priori, that model of interaction works. It broke down with the web. So they were drawing the box around an office, and everybody within the office was assumed to be able to do what any one of them could do. When the web came along, that model of interaction broke down, and Netscape came up with this really brilliant idea. Let's draw the box around the service provider. So if you're interacting with a website, the scripts and the scripts and frames from that same origin can all interact with each other, and they have certain privileged access via things like the XML HTTP request object to talk back to that to the backends for that domain. That is breaking down around social networks. So a lot of social networks, you've got mashups, you've got code from different sources trying to pretend to be part of one application. And so you've got a container in, for example, iGoogle, and it's embedding little bits of JavaScript here and there. and you've got a lot of other applications that might want to embed third-party content. And right now, they're frequently doing that via iframes. And iframes are a way of allowing multiple origins to interact on the same page, but the interaction is often very painful. It has to go through proxy servers, or you're using cross-site script tags to communicate to other backends to get information. And that works as long as you trust everybody who's involved in that loop. But it's very hard for a user to know who it is they're trusting with that data. And the box is getting much bigger, so you have to trust everything within it. Caja is trying to make those kinds of interactions much easier. So and the problem with the same origin model is that you've got this box which is drawn around a service provider, but there's no way to poke holes in it. So if you've got these two boxes that are separate, they're entirely separate. And people have found ways around that, mucking around with the hash on window.location and being able to use a shared iframe to send messages between. But by and large, it's clunky, and a lot of those communication mechanisms end up, you're sending a string over and then somebody evals it, which you're throwing all the security out of the window. So Caja replaces that model with one where the boxes are very small. The boxes are at the level of a JavaScript object, but you can poke holes in it. So these objects are allowed to access each other, call methods and so on, in a way that makes it possible to reason about what they can do. And so I should probably explain what I mean about security. So we want gadgets to be able to cooperate, different pieces of code from different sources to be able to cooperate, but we don't want them to be able to interfere. And there's a fine line between cooperation and interfering. But in object-oriented programming, people are already very familiar with the concept of public APIs versus private APIs. So if you've got two people writing two modules of the same program, those modules interact via the public APIs, and each person who's writing one of those modules knows that if I'm careful about the public APIs, then I have some guarantees as to what that other module is going to be able to do. And then they're able to have their private APIs be as expressive as possible without worrying about another module coming in and mucking around with their internal, so they can really maintain the invariance that they need to maintain. And what do I mean by source code rewriting? So we've got this compiler, which takes CSS, JavaScript, and HTML. We actually call it a cajoler. And one example of a transformation that we do to code is if we have input code location equals evil.com, that would cause the page to redirect to another page, and maybe that page is a phishing page or something, or it causes a pop-up that causes you to download malware, or it does something else that's bad. We rewrite that global reference to location to instead point to something that we call imports. And so instead of actually having access to the global page objects, you have access to a proxy that we give you. So we might put in a location which, when it's assigned to it, it checks and says, you're allowed to redirect to this URL, or you're not allowed to redirect to that, or we force you through a proxy server to do those checks. And if you were to use document.createElement, we've created a proxy for document which can whitelist which elements you're allowed to create. It can do transformations on attributes and other kinds of things. So if you do document.createElement of script, we can say, no, you're not allowed to dynamically execute script outside of the system. Or if we can allow you to create a script, but then if you try to set its source, we can force that to go through a proxy which also cajoles the JavaScript from there as well. So I'm going to show you a demo. At Google, I guess I should explain a little bit about what we do at Google. We muck around with search engines a lot. So indexing this and caching that and all kinds of search engine nonsense. When we're not messing around with search engines, a lot of what we're doing is we're searching for pictures of cute kittens with funny captions on them. And this is an application which allows you to do that. And so there's two gadgets contained in this page. One of them is a search box. It's a text input and a submit button, and you type in what you want to search for, and you hit submit, and then it goes and searches the web and shows you a list of results. And then there's a kittens gadget, and the kittens gadget wants to know when you click on a result, so it can take that result and there's a snippet associated with it, do a search for that, and it also adds kittens to the text, and then it'll display you a picture of a kitten with a funny caption. And allowing a gadget to access an arbitrary URL, such as a search engine, is giving an awful lot of authority, but it really needs to be able to go out to the web to do its job. So this container creates a search engine object which can search the web. And that search engine object uses some Ajax APIs to go out and grab search results. And both of those gadgets have the authority to search through that search engine object, even though they don't have the authority to craft a request against an arbitrary URL. So at the top, I've got my search box gadget, and it's a box and a button. And it displays some search results on the right. When I click, the search box gadget sends a message to the kittens gadget, and the kittens gadget displays an API. And these gadgets are not in iframes. They're operating in the same frame. There's no box that you can draw around either of them, which defines an iframe boundary. And each of these gadgets is just written as an HTML file, and that HTML file contains scripts which load other JavaScript files. It contains link and style tags, and the first thing that our compiler does is it pulls these HTML files apart. It says, what are all the scripts here? And it looks in script tags, it looks in on-click handlers, all the places where you might expect to find JavaScript. And it does the same for CSS. So it looks in link, it looks in style attributes. And it takes the HTML and it turns it into JavaScript, which generates that same HTML. So at the bottom there, you can see that it's starting a form tag, it's adding an onSubmit attribute to it, then it's injecting some content, which is kind of an optimization, and then it's ending that. And so we're turning the HTML with script interleaved into script with HTML interleaved. And if you see the onClick handler on the button, it calls this doSearch function, which is specified in that JavaScript file. We turn that into a wrapper which goes through an event dispatcher. That event dispatcher then sits in the middle between actual event handling and the JavaScript code that receives that. And another part of non-interference is making sure that when styles are specified, those style rules are, of course, global. But if one gadget decides that the p tag should be purple and another gadget decides that the p tag should be pink, we want the purple guy's p tags to be purple and the pink guy's p tags to be pink. So we take style rules and we prefix them with a class match that guarantees that they will only apply to DOM subtrees that have a particular class. And once we've got all the JavaScript in one place, we can go ahead and do some of the transformations that I showed you before. For example, we can take all the global references and namespace them, and then we've got imports.document now refers to a proxy for document that can attenuate a lot of the authority that document provides. And after that, the container needs to load the gadget. So it specifies a place where the gadget's HTML is going to end up, and then it sets up this fake global scope. So it creates an imports object for that gadget. It attaches a document to it. It creates an HTML emitter, which is what takes the JavaScript generated from HTML and actually dumps it in a particular place. And then it loads the gadget by simply including a regular script tag. And it wants to provide access to the search engine object so that the gadgets can search the web. And providing access to that is as simple as attaching it as a property on this global object. So now searchbox imports.searchEngine points to a search engine object. The gadget code can say searchEngine.search the web. And it also wants to allow these two gadgets to interact. That's as simple as copying a function from one to the other. So a gadget, since it's represented as this imports object, is basically an object, and you could copy that object over as well and give access to the entire public API. But for this demo, we just copy one function over. And so now we've got a bunch of gadgets in the page that can, in fact, search the web. And why is this useful? Well, as I was talking before about large boxes and boxes without holes in them, the current interaction between iframes, you've got a couple. If you're a container and you want to include untrusted third-party code, you've got a couple options. You can trust it, which is fine if you know them and they're nice people. But that doesn't allow you to take advantage of a lot of code that you might otherwise want to put onto your site. Or you can put them in an iframe. And iframes have some problems. If you've got two iframes interacting, there's ways to send messages between them, but those ways of sending messages are clunky. You end up often turning things into a string and then trying to parse that on the other side, and there's a lot of inefficiency in that. Or you can try and send things through a backend and have code in the other frame polling it. And that is also inefficient. Or with Caja, you have the code running in the same frame, and sending messages is as simple as just calling a method on that object. So the normal way in which people deal with objects in an object-oriented language, Caja piggybacks authorization information on that. Since you have access to this object, that means you have authorization to use its public API. And we guarantee, and if you're trying to reason about what authority does a gadget have, you only have to reason about what objects did I give it access to. And if a gadget wants to reason about what authority am I giving up in dealing with this other gadget, then it only has to reason about what objects am I returning via my public API. And object capabilities is a security model whereby reference implies authority. So it assumes you've got a clear separation between public API and private API, and that's enforced. In this case, we're enforcing it at the language level. And it assumes that you can only influence the world by sending messages on references. So, for example, by writing to a particular memory location, if that can cause access to a file, then you don't have an object capability language. And if objects are encapsulated if, for example, in C++ you can cast away constness, or you can cast to a void pointer and muck around with internals, or you can try and guess name mangling, then you don't have encapsulation. So Java, for example, is a language which has the first two, but it doesn't have the third, so it's not an object capabilities language. And the third is very important. So an object's creator can deny access by not providing references. So within Java, there's no way to deny access to a file that the user running the application has access to. You can always just say new java.io.file, give it an arbitrary path, and you've got access to a file object. So in an object capability language, the container may decide that you have access to certain files, and so it provides you with access to certain file objects, but there's no factory out there which takes an arbitrary string and turns it into a file object. And object capabilities is really just building on existing object-oriented practices. So instead of coming up with an entire scheme of administrating access control lists or trying to keep track of this user has access to that, we're piggybacking authorization on reference. And so when you're trying to write an object-oriented program, maybe you decompose things using separation of duties. This piece of code is the front end, and it needs to be able to draw a UI and respond to events, but it doesn't need to be able to contact the back end. And this is my transaction layer. It needs to contact the back end, but it doesn't need to be able to render a UI. And so those separation of duties imply also a separation of authority. Each only needs certain access. And information hiding is where you keep your implementation details separate from your public API, and that plays very well into encapsulation, providing authority. And one of the nice things about capabilities is that they provide very flexible security. So whereas with the same origin model, you've got this code which says, okay, a frame is trying to access a certain URL, or an XML HTTP request object is trying to access a certain URL. My policy is that, if it's in the same domain, I allow, otherwise I reject. That makes it very hard to punch holes in these boxes and allow them to interact along safe channels. Whereas, since object capabilities draws the box so small and makes it very easy to punch holes in the box, those holes just being the public API, it ends up very flexible. If, for example, you have a DOM node and our DOM node implementation allows setting of inner HTML, we may sanitize that and remove script tags and other things, object tags and the like, but we can make an exemption for a no and safe source. So if you have a user's HTML signature, then we know that came from a trusted source. We can mark that in some way that the DOM node recognizes that. Or if you know that you have a rich HTML editor, we can also just assume that a priori that produces good content. And templating systems can tie into that as well. So if you have a templating system, you can move a lot of the runtime analysis to compile time. And I guess, so where are we? Caja is not usable today. We have the language specification stable. So we're specifying a subset of JavaScript. We've removed a couple things which make it very hard to reason about the language, such as width and a number of the weirder semantics around the arguments object. But it's a very large subset of JavaScript. We've got this cajoler implemented, so we're able to take apps and run them today. We've got a prototype of the tamed document, which sits in between the untrusted code and the frames document. And we've prototyped various debugging and IDE support. We started having people attack it and are trying to get an idea of where the weaknesses are right now, but we haven't been attacked enough that we're confident saying that it can be used. And we still need to do a lot of optimization to reduce the runtime overhead. So if you're interested in Caja, our code is all available under the Apache license, and we're developing it and having development discussions on that Google group. And the demos are all up on that site. And feel free to email me with any questions. I guess that's my presentation. If anybody has questions, just line up with the mics. We want to be able to say that it's ready for use within an iframe as an additional security measure kind of next quarter. And then hopefully the quarter after that it'll be ready for use without the iframe boundary around it. So right now we protect against some attacks that iframes themselves don't protect against. So setting window.location and phishing to another place or causing download of malware. Existing iframe jailing doesn't solve that, and we do. So, yeah, and we've got a couple other clients as well who are planning on rolling it out as well. I'm afraid I'm not familiar enough with the map API, but I imagine that if it won't work as is, then we can figure something out. Yeah.
I've got a question about the use of XHR with this. I understand how it allows us to put everything together and not have to, makes it, interaction among the objects much simpler and much more performant. But it doesn't help us get around. Or am I correct in thinking it doesn't help us get around the same origin with respect to XHRs?
All XHR, there's a number of ways to get around that right now. So I think a number of people are planning on writing an XDR, cross-domain request
right.
that kind of bundles all those together. One of the parts that the container provides is a URL policy. So if we see an image source in the cajoled HTML, that can be rewritten to go through a proxy ahead of time, and a lot of those other things. So that's the way in which a container would specify you're able to access, these URLs and not those.
Okay, so it doesn't open up possibilities, but it lets us do smart rewriting and clamp down on things.
Yeah, you can pass everything through a cookie stripping proxy, for example, to prevent XSRF attacks and that sort of thing.
Cool, thanks.
Yeah. Any other questions? If the JavaScript is being dynamically generated, in that case, we've got to fetch that and pull it in. We do have a proxy which will do that. Of course, that's going to add extra latency. So under normal circumstances, things would be cajoled and then cached. But the more dynamic JavaScript there is there, the more latency you're going to see on loading things into the container.
Thank you.